An important concept in statistics is that of a simple random sample. Now, random sampling itself is important, and we'll be talking reasons for that. One reason you'll frequently hear is that we want our sample to be representative of the population. So how we select that sample is critical to the work that we do in statistics. But we'll spend a little more time talking about that at the conclusion of this video. A simple random sample is just a special type of random sample. It has special characteristics that we are going to discuss. But it is a random sample, just a special type. So in order to understand simple random samples, we want to review some of our previously mentioned definitions. So the first being that what the population is. A population is our total set of observations that we are going to make our selections from. The sample then is this representative group that we have drawn from the population. Remember this term parameter. It's a measurable characteristic of a population. Remember how we noted how we could remember parameter is a characteristic of the population, and then a statistic is that measurable characteristic of a sample. And we'll be talking about these. Examples of those are the mean or standard deviation. So usually we don't have the mean of the entire population. The population is too large for us to measure every member of the population. So we will get to the point in the course where we will be estimating what we believe the mean of the population is based on what we find the mean of the sample to be. So the sampling method then is our procedure for selecting our elements from the population. And what we're talking about here is the sampling method that is called the simple random sampling method, where our result is a simple random sample. Okay, so here's our definition of a simple random sample, or the important properties involved there. We have N objects in our population, that's capital N. And our sample size is lowercase n. And what the simple random sampling method says is that all possible samples of size n, so you've determined how many you're going to select for your sample, maybe it's 20 objects or 50 objects or 10 objects, but all possible samples of that size are equally likely to occur. They have the same chance of being selected. Okay, what's different then about a random sample? We said a simple random sample is a type of random sample. But when we talk about random sampling, all that means is that every member of the population has an equal chance of being selected. But it doesn't say anything about every sample of size n. Just every member has an equal chance. So we have this additional case right here. This is what's different about simple random sampling versus just general random sampling. And we're going to look at the difference in an example. Okay, so our current president of the college will be leaving us in the fall, and we will be getting a new president. So for the purpose of this example, let's say that it's fall and the new president is on campus for a reception, and during my class I've been asked to select 4 students to go and greet the new president at a reception. So my class is situated like this. I have students in every desk, and so my population of students, my capital N, would be I have 6 rows of 4 students in each row, so 6 rows times 4 students in each row, I have a population of 24 students to choose from. Okay, and I've been asked to select a sample size of 4, so my lowercase n is 4. In a random sample, the requirement is every member of the population, let's look at that definition again, every member of the population, every one of these 24 students would have an equal chance of being selected. So a random sampling method would be, a very simple one, would be that I would maybe number the rows. So let's see. This would be row 1 here, row 2, row 3, row 4, row 5, and row 6. So a very quick way to do this would be to number the rows, put each of those numbers on a small piece of paper, drop them in a little box, shake it up, make a selection of one of the numbers, and say I chose 5, and so these would be my 4 students that were selected to go to the reception for the new president. Did every student have an equal chance of being selected? Well, we would say that every student had a 1 out of 6 chance of being selected. And we'll get more into this chance or probability in Chapter 4. However, we can see here that there are 6 rows, and each student, is in one of these rows. So there's a 1 out of 6 chance that a student would be selected. So every student would have an equal chance of being selected. This is a random sample. Now, there are many other ways to do a random sample, but this would definitely be a random sample. To be more specific and have the requirements of a simple random sample, we'd do things a little differently. So let's look at another example, the same example but in a different way. So here's my classroom, and we're still going to do the same things here. We've got a population n of 24, and my lowercase n, I'm going to select 4. But what the simple random sample says is that every possible group of 4 has an equal chance of being selected. You see how that's different from what I did in the other example. In the other example, there was no chance that the first student in row 1 and the third student in row 2 would be going to the reception together, right? Because if the first student in row 1 was selected, that meant row 1 was selected, all of these students. So there's no chance I would have this student and the third student in row 2 and maybe the last 2 students in row 3. That combination would never occur if I'm selecting by row. However, if I'm conducting a simple random sample, then every possible combination of 4 is possible. So I cannot select by row. So how could I do this? Well, I could number my students 1 to 24 and use the random number generator on my TI-84 and ask it to give me 4 integers that fall between 1 and 24, and then that could be any combination of students here. Or again, I could have the 1 through 24 written on little slips of paper and put them in a box, shake it up, and draw out 4 numbers. So a simple random sample, I could potentially get this student, and perhaps these 2 in a group. Those could be my selected 4. This could never occur if I was selecting by row. What's every student's chance here? Well, in this case, there are 4 students that are going to be chosen, so you have a chance of 4. 4 names are going to be called. So there are 4 opportunities for your name to be called if you're one of the students out of 24 students. So everyone has an equal chance of being selected, just like a random sample. Of course, this would reduce to 1/6. Every student has the same chance of being selected, but we have that additional requirement that all possible samples of size 4 have an equal chance of being selected. So this is an example of how you can tell the difference between a simple random sample and just a general random sample. Now remember, this is a random sample. what I showed you above was also a random sample, but this is the specific type of random sample called a simple random sample. So why, I said we would conclude with some information about why simple random samples are important. So why is this so important? Well, of course, as I mentioned, we do want our sample to be representative of the population, and by choosing randomly, hopefully we achieve that. But the most important reason for using a simple random sample is that the mathematical theorems we are going to use apply only to simple random samples. So we have no option. If we're going to use the theorems that we will be using in the book, a simple random sample is required.